All right, welcome to Monopoly Part 2 tonight. I want to jump right into this because there's a lot of stuff I want to show and do. So I'm not going to waste any time with small chat tonight. I'm going to go ahead and turn off my video and get going here. So I'm sharing my screen with you today. Like I say, this is Monopoly Part 2. Uh, Last week, I went over imperfect competition, and I just introduced the idea of what imperfect competition is. Imperfect competition consists of monopolies, which is what I talked about last week, oligopolies, and monopolist competition, which is what will be next week. So next week we'll do it's the um, MCO, monopolistic competition and oligopoly. That's it. That's the unit. They're the module that we'll do next week. Okay, but all these guys, monopolies, oligopolies, and monopolist competitors are what we call imperfect competitors, meaning not perfect competition. And the idea behind imperfect competition is that in order to sell another unit, the firm has to lower their price to sell additional units. Where with perfect competition, since a firm is a price taker, they can sell as many units as they want at that market price. But all of these guys are going to face a downward sloping demand curve. Every one of them is going to face a downward sloping demand curve, and their MR is going to fall at a faster rate. We'll talk about the other two, monopolist competition, oligopoly, like I say, next week. So there's that. So we said, remember a monopoly, one seller, no close substitutes. They're what we call price makers. They still have a downward sloping demand curve, but they're price takers. That they determine their quantity and then set the price based on what quantity they're profit maximizing quantity. And entry is generally blocked for whatever reasons. Okay. Um, so this is what the monopoly looked like last week. I showed you this. Okay, and what we're going to do is we're going to use this today. So if you've not watched the video from last week and you're not very familiar with this monopoly and what it looks like, please go back and watch that video and study this stuff because you're going to be expected to be able to do that here in just a second. So what I'm going to do today is I'm going to show you what I call a super FRQ. All right. If you can do everything I'm showing you right here, then there's no concept that they can ask on the AP exam about monopoly that you can't answer. Now, you may have to be able to draw it because I'm actually going to give you the graph and we're going to find all these things. But I'm telling you that if you can do everything here, draw monopoly, and then do everything you can do here, you've got monopoly whipped. There's nothing that Georgia Virtual can ask. There's nothing that the College Board can ask that you will not understand. Okay, so make sure you can do this. This is what I call my super FRQ. I put this together. This, like I say, every possible thing they could ever ask. All right. So what I'm about to do is, if you have not already done this super FRQ that I'm about to show you, go ahead and stop and do it. Okay, and then join me because I'm about to go over the answers. Now, where's this thing located? If you go to the class resources section, that's where all my notes are. Okay, and so these are all my notes. These are all the notes that I hope you've been using all along, right? This is the Monopoly notes right there. Right below that is this Super FRQ, and then below that is the rubrics. Now I'm about to go over the rubrics, but there's the rubrics also written out for you there. Okay, so this is all my notes here. Hopefully you've been using them and printing them off in addition to these live learning sessions. So here we go. This is what it looks like. Again, last chance. If you haven't already done so, then you need to go ahead and stop this video and do this on your own because you'll get way more out of it by doing it on your own first. All right, here we go. So question number one says profit maximizing output level and price. Explain. Okay, so the idea here is, first of all firms produce where MR equals MC. So the quantity is going to equal to 5, and the price, to get the price, you always go up to the demand curve. So the price would be $18. Oops, should have done that a little lower. So the price is $18. Now, that's locating it. What about explain? The idea is would say that all firms produce where MR equals MC and that the price comes from the demand curve. And if you said that on an AP exam, they would give you full credit. Okay, now they're probably not going to explain something like that, but I always say explain because of the MR equals MC thing. I always make my students explain it because all firms maximize profit by producing where MR equals MC. So you find that magic point, and that then you come down to get your quantity and go up to get your price. Okay, now there it is. I forgot that I have the answer in here for you. Okay. And number 2 says at the profit maximizing level of output, is the firm earning an economic profit or loss? Explain. Well, if you look at this here, all firms produce where MR equals MC, 5 units, and at $16, price is $18, and the average total cost is $14. And since 18 is bigger than 14, this firm is indeed earning an economic profit. Okay, the difference between profit and loss are different. To define profit or loss, you always go between the difference between price and average total cost. And in this case, since the price is 18 and the average total cost is 14, then they're earning actually a $4 per unit profit, which is, I think, the next question. Probably should have given the answer. Yes. At the profit maximizing level of output, calculate the area of total. No, it's not the next question. Calculate the area of total revenue. Show your work. In economics, anytime they say show your work or calculate, they want you to give the economics formula, is if there is one, put in all the numbers that count, and then solve for it. So total revenue is price times quantity. So you had to write the total revenue to get credit for this. You had to write the total revenue is price times quantity. We know at 5 units, the price is $18 and the quantity is 5. So 18 times 5 is $90. So this firm is bringing in $90 of total revenue. Next question, at the profit maximizing level of output, calculate the area of total cost. Okay, well, total cost, if you can remember way back when we learned all about the different types of cost curves, I said you have to be able to calculate all the different cost curves. And one of the reasons why, when we did that chart, you had to be able to calculate all those cost curves is for just a question just like this. Okay, total cost is average total cost times quantity. So total cost is average total cost times quantity. Well, we already figured out that a profit maximizing quantity of 5, the average total cost is 14. So the average total cost is 14, and we're producing 5 units. So on average, it's costing us $70 to produce this product. Next, it says at the profit maximizing level of output. So if you just joined us, I'm going over the Super FRQ. I want to just make sure I hit this real quick for people that just jumped in. The Super FRQ is located in the class resources. Okay, and once you get there, it's right here, and this is a Super FRQ. And if you have not already done it ahead of time, you'll get something out of what I'm doing now, but you need to make sure that you can do these on your own, because if you can do all of this, then you will be ready for anything they ask, that Georgia Virtual asks or the College Board asks. The difference is you have to be able to draw the graph too. They may make you draw the graph to show total revenue, to show total cost, things like that. So just because you can calculate it or tell me where it is on the map, if you can't on the graph, you can't draw it yourself and then do it, then they may say shade in the area of total revenue. So there's the area of total revenue shaded in right there. Okay. Or they may say shade in the total cost, which would be this area right here. So they may make you draw the graph and do it, but if you can do it with the numbers and the graph I'm giving you, you should be able to do that as long as you can draw the graph. All right, then number 5 says at the profit maximizing level of output, calculate the profit per unit. Be very, very, very careful. This is per unit profit, not total profit, right? And the idea here is if we're charging $18, if this firm is charging $18, but on average it's costing them $14, then their per unit profit is the 18 minus 14 or $4. Okay. And again, you're reading it over here, 18 minus 14. You're not reading it in here. You're not reading it right here in this area right here. You're reading it on the axes. Prices and quantities always come from axes, not from internal part. That's why you lose points if you labeled this. If you said this is price right there, you lose the point. That is not price. That's a point inside the curve that we get our price from that point on the demand curve. Okay. Next, it says at the profit maximizing level output, calculate the area of total profit or loss. And of course, they put profit or loss because some people earlier might have thought they were earning a loss, and of course, they're not earning a loss. Okay. Well, how do we get total? Well, what you do is you just take, there's two different ways you could do it. You can either do total revenue minus total cost, which is the total revenue. I'll just draw it in real quick like this. There's your total revenue minus your total cost, right? And that would give you your economic profit. That's your economic profit right there. And we already calculated total revenue way back here as, well, total cost is 70 and total revenue is 90. So it would just be 90 minus 70. So that's one way of doing it. Okay, so it could have been 90 minus 70 is $20, right? But the other way to do it, and probably the way they're going to want you to do it on the AP exam, they're probably not going to give you total revenue, total cost. What they're going to give you is they're going to give you a situation where you know that you take price minus ATC times Q. So price is 18. Average total cost is 14. So it'd be 18 minus 14. You're making $4 per unit and you're selling in profit and you're selling 5 units. So it would be 18 minus 14 times 5, which is 20, or 4 times 5 is 20. So that would be just, if they said calculate the area of economic profit, you could do that. Okay. Next, at the profit maximum level output, calculate the area of consumer surplus. Okay. Good, our good old friend consumer surplus. We've seen him before. I've warned you that you'd see this many times over. At that quantity, our price is 18. So where's our consumer surplus? Consumer surplus is everything above price to the demand curve. So it's the area of the rectangle here. Now it says show your work, but there's not an economics formula here. So you don't have to write the formula 1/2 base times height. But what you do have to do is write in all of the relevant points. Okay. I like to do base times height divided by 2 to do the area of a triangle, as opposed to 1/2 base times height. It's just easier to do it this way. It's easier to show it on an economics test too. Okay, so the base, always use price as your base. Okay, always use price as your base. So what you'd have to do is it is 28 minus 18 times 5 minus 0. Okay, 5 minus 0. You can't do just times 5 because we don't know where you got that 5 from divided by 2. Okay, so be careful of that. Whenever you're calculating areas of triangles, always show the whole thing. Of course, what did I do? I did it just times 5 here. Okay, so it should have been, look at my, now don't look at this right here. Look at this right here. It should have been times 5 minus 0. Okay, because that way we know where you got one. One like this, I think on the actual AP exam, they would give you that. I think the powers that be would say, look, man, it's a quantity of 5. They've already told us the quantity is 5. They know the quantity is 5. So they would probably give it to you. But just to be safe, always give the full 4 numbers that go with the triangle. And of course, you divide by 2. And the answer, therefore, would be $25. All right. Calculate the area of producer surplus. Producer surplus is everything below price to the supply curve. And you go, but wait a minute. Monopolies don't have supply curves. You're right. Monopolies have a supply point. That point right there is actually their supply point. But what we do is we do a little hand waving. You know, these are not the Jedi. I mean, these are not the droids you're looking for, Jedi mind trick, things like that. We play like this marginal cost curve is a supply curve, because if this were perfect competition, then this would be a supply curve. So we play like it's a supply curve. So the area of producer surplus is everything below price to there. And then notice how I drew it as a straight line. If they're going to make you calculate on the AP exam, they're going to draw this marginal cost as a straight line, and they're going to run it all the way to the axis. It may not run to 0. It may run to 2 or 4 or whatever it may be. Just I could change the slope of this marginal cost curve. As long as it goes through the minimum ATC and it's upward rising, then we're okay. I've actually seen it where they've drawn, and this is a different type of monopoly, but where the marginal cost curve actually looks like this. Okay, that's because the economies of scale have not happened yet. It hasn't not economy of scale. It's where the marginal cost curve has not started rising. It will rise eventually somewhere over here. It will rise, but we do it as just a constant marginal cost curve. And that's a different type of thing here. And so if they drew where to draw one like that, don't let it throw you. Just solve it like it's just a regular marginal cost curve that you already know up here. So, right, so how do we calculate the area of this strange shaped figure like this? Well, what you do is you go in and you divide it and you do the area of a rectangle up here and plus the area of a triangle down here. Okay, and if you do that, then you're going to get this number right here. It's 18. I probably should have stayed where I was, but it's this area right here. So it's 18 minus 10 base times height. Height is 5 minus 0. And of course, I just did 5. Should have done 5 minus 0. Plus base, which is 10, the triangle here, minus 0 times 5 minus 0, and then divide this part by 2. And when you do all that, you end up getting 65. So a little bit of math here. You are allowed a simple calculator on the AP exam. The AP exam will be pencil and paper, not will be pen and paper. But they also will still be, the questions will be on the computer. So you'll be able to use the calculator on the computer if you so choose, or you can bring in your own simple 4-function calculator, one that has no memory going into the test. So anyways, and use it. Use the calculator, okay? Because if you do 3 times 3 is equal to 10, you will lose the question, even though you gave the correct setup 3 times 3. They do expect you to be able to do math. So just be careful of that. All right, then last but not least, but next part of this, we did consumer surplus, we did producer surplus. Well, why are monopolies so bad? One of the reasons why monopolies are so bad is they're not perfect competition, and there's dead weight loss created. So next, they want to know where's the dead weight loss. Calculate the area of the dead weight loss. Okay, and again, if they made you draw this, they wouldn't say calculate the area of dead weight loss. They would say shade the area of dead weight loss. And the area of dead weight loss is this triangle right here. Okay. So what we have to do is just calculate the area of that and its base, which is, oh, and then I always leave it here. Where am I? Right here. Okay. The area of triangle is right here. So it's base. So it's going to be 18 minus 10 times 7 minus 5. Should have been dotted lines all up like that. No, should have been dotted lines. Okay. 7 minus 5 divided by 2, or $8. Okay. Now, dead weight loss, let me clarify this here. Dead weight loss occurs anytime you're not producing the allocated efficient point. Well, where's the allocated efficient point? Allocated efficient point, by definition, right here, this is where price is equal to marginal cost. So the allocated efficient point is right there, right? And that's why the dead weight loss is this. What did I do wrong? Oh, I went to the wrong spot. I went to ATC. Sorry about that. I misread my graph, looking at it too close. Right there. There's allocated efficient. So 7 is the allocated efficient quantity. And that creates that dead weight loss right there. Next, identify the range of demand curve where the demand is elastic. Explain. This is a good one. They will often ask you, at a quantity of 10, is demand elastic or inelastic? At a quantity of 22, 23, is demand elastic or inelastic? They'll ask you questions like that. This is just saying, hey, go in here and identify the range of the demand curve where demand is elastic. Well, if you'll remember that demand is elastic anytime marginal revenue is positive. So when MR hits 0, then that's when you turn. That point right there is the unit elastic point. Everything to the left of that is elastic, and everything to the right of that is inelastic. Okay. So what you would say here is the answer is, oh, they just said identify it. So from a quantity of 0 to 8 units, you identify it based on quantity. So from a quantity of 0 to 8 units, right there, demand curve is elastic. Okay. Interesting enough, because if you actually try to use the total revenue, and I apologize for you guys that did this, if you try to use the total revenue approach to prove it, then you would not get the right answer here. Okay, and the reason being is I just drew this on graph paper. This graph is actually not mathematically correct. Okay, it's not possible. The way I drew the MR and the demand, because this demand curve is supposed to hit the midpoint. I'm sorry, but this MR curve is supposed to be 0 at the midpoint. So really, if I drew it, if this extended all the way, then it should be, the midpoint should be right here. That should be the midpoint. So the demand, this MR curve should actually be sloped like that and go to that point right there. But if I did that, notice your MR equals MR equals MC point is not on an equal quantity. And so what I did is I sacrificed this question to make sure that this wasn't a 4.7 or 4.75 or something like that, because the rest of the time you'd be driving you crazy with those numbers. So I apologize that the math did not work on this. It's because I violated a mathematical rule to make this work. But I promise you, if you always use this in your explanation, then you don't need to worry about that. Okay. Anyways, it spends a lot. It's a lot harder to do the total revenue thing anyways. Just when MR is 0, your unit of elastic, everything to the left of that is elastic, everything to the right of that is inelastic. So identify the revenue maximizing level of output. Okay, the revenue maximizing. Well, revenue is maximized when total revenue is at its highest, right? Well, total revenue is the sum of the margins. So as long as marginal revenue is positive, total revenue is going up. So the revenue maximizing quantity is 8 units. Because total revenue is, marginal revenue is positive, 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 positive. When it hits there, it starts to go down. So if I were to come underneath this and draw another graph like this, okay, there's price and quantity, total revenue would do this. And that would be total revenue would be maximized right there. Right? And that's also the basis of the total revenue approach that I just showed you a minute ago, or that I said wasn't right, is that set of graph right there. So, all right, next. If the firm chose to maximize output without earning a loss, what level of output, not an exact quantity for this graph, would they produce? Again, because it's so hard to draw it, where every question works exactly perfectly. Okay, where would they maximize their output without earning a loss? Okay, well, where, as long as price is greater than ATC, they're earning a loss. If price is less than ATC, price greater than ATC, they're earning a profit. If price is less than ATC, they're earning a loss. So where would they maximize their output without earning a loss? When price equals ATC. So it would be right there. When price equals ATC. So it'd be 7 point something units. So right in there. So where they would maximize, that'd be the quantity where they would maximize their output without earning a loss. Okay. They'll talk this, the idea behind this question is that if this was like a nonprofit organization, well, nonprofit organizations can't continuously stay in existence if they're earning a loss. And so they would try to shoot for 7.25 units as opposed to 5 units, which is what a profit maximizer would do. All right. Identify the socially efficient output level. Okay. Socially efficient is a fancy name for allocative efficient. We use them the same way. You can actually use them interchangeably. They're not really exactly the same thing, but in this course, you're more than welcome to use them interchangeably. Socially efficient and allocative efficient. Bottom line, it's where price is equal to marginal cost. Okay, so where's the socially efficient level of output? It's where price equals marginal cost, which would be right here, which is 7 units. Okay. At that point, there's no deadweight loss. At the socially efficient output level, is the monopoly earning a profit or a loss? Well, let's take a look at it. At that point, remember the demand curve is price. Price is $14. And average total cost at that quantity is, looks like about, let's say 13, right? So they're actually making a $1 per unit profit. And at that quantity of 7, they're producing 7 units. They're actually making $7 in profit. Not as well as if they decided to profit maximize and produce way back here, right, where they're making $20, right? Back here, if they go where MR equals MC, they're making $20 in economic profit. Where right here, by producing at that point right there, they're just making this little small area right there. I should have meant that different color. Hit the button, it didn't work. So that red part is only $7. The green part is 20 bucks. So it looks better. It looks like it's a bigger area, but it's not. If you do the math on it, it's not. So anyway, so profit maximizer versus allocated efficient or socially optimal. Profit maximizing is 5 units. Socially optimal is 7 units. That socially optimal output identified the area of deadweight loss. Trick question: when price equals marginal cost, there is no deadweight loss. The AP exam would probably not tell you to identify it if there wasn't one. What they would say is, they might say, is the deadweight loss larger, smaller, or equal to something? You know what I mean? That they would know you would have to compare it to something. But I didn't have a problem tricking you on this because I'm not taking this up for a grade. So there's no deadweight loss. This is optimal. Again, not meant to be a trick question. Blah, 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 blah. Okay. Between $16 and $14, the firm experienced economies of scale, constant returns of scale, or diseconomies of scale. Explain. Okay. So in this range between 14 and 16, right here, what are they earning? Well, economies of scale is when the ATC is going down, the ATC, and this is actually a long run average sold cost if you want to do economies of scale. But again, this is kind of a little Jedi mind trick we play in this course. And don't worry about the fact this will do long run average sold cost. If I ask about economies of scale, you just got to know it's long run average sold cost, right? But anyways, long run average sold cost is when the long run average sold cost is decreasing, you're experiencing economies of scale. When the long run average sold cost curve is increasing, you're earning diseconomies of scale. Constant would be just this one area right there, right? That would be your constant returns to scale. And people go, well, so it's just a point? No, because everybody's curve doesn't always look the same. You can actually have a long run average sold cost curve that looks like this. You can actually have one that does like this and it just kind of goes flat for a while and then comes up. So you've got this huge area of constant. That's not accurate because there's the lowest point should be that flat area. But anyways, you got this huge area where you're getting this flat constant returns to scale. So you've got diseconomies of scale over here, right, where it hits there, and you got right there. So you got your different ranges there. So, but anyways, and for this one here, so the idea is there any economies of scale, constant return to scale, diseconomies of scale? In that range, we are right here, right? So what's happening to that average sold cost curve right there? Well, it's going up. That means you're earning diseconomies scale. Okay. And I put decreasing returns of scale, should be diseconomies of scale. They're different things. Remember, returns to scale Decreasing and increasing returns of scale has to do with inputs and outputs. If I put 5% in and get 10% out, I'm getting increasing returns to scale, right? This economy of scale has to do with the slope of the curve. Returns to scale has to do with inputs to outputs. Suppose the government regulates the firm's price to produce at the allocated efficient level. Identify the output level and price. Explain. So this is where the government has come in and said, you're not allowed to maximize profits because you're an evil monopoly. Instead, we're going to regulate you. We're going to regulate you to produce the allocated efficient level. Allocated efficiency is where price equals marginal cost. So the government's telling them they have to produce 7 units. Okay, they have to produce 7 units where price equals marginal cost right there, right? So they're now going to charge $14. So the price is going to come down. So the quantity is going to equal 7 and the price is going to equal to $14. And students always say, well, that's dumb. Before they were charging 18. Why don't they charge 18 now? Because 18, if they're going to produce 7 units, 18 is not on a demand curve. So they're basically, they can't charge 18. They're not going to be able to sell 7 units, right? They're only going to be able to sell 5 units. And the government has basically said, you have to sell 7, right? Now, the way the government usually does this is they regulate price. They don't regulate quantity. What they do is they tell them, hey, you can only charge $14. So they basically put in a price ceiling. They put in a price ceiling at $14, like the post office. The government regulates how much the post office can charge for a stamp. Why? Because it's a monopoly. And a lot of people don't agree with that, because you got FedEx and UPS and all those guys. Well, FedEx and UPS don't go to every house every day. Okay. Now, if you order a lot of Amazon, it may show up at your house every day, but for the most part, it doesn't go to everybody's house every single day. Post office is a monopoly. And so the government regulates them, not obviously at $14 per stamp, but we're getting there. Okay. So again, I already said that answer. Produce 7 units, and the price would be $14. And oh, by the way, yeah, at that point, total surplus is maximized because there's no deadweight loss. Okay. So if they regulate them right there, then the consumer surplus is this big area right here, and the producer surplus is this big area right here, and total surplus is maximized. And they could actually ask that question. I don't think I do. I think I said at the beginning that I could have asked you everything you could possibly do. They could ask you the change in consumer surplus or the change in producer surplus. So before the consumer surplus, let me go ahead and backtrack and do that real quick. Before the consumer surplus was everything above price. We were producing 5 units. It was okay. This was the consumer surplus. And so when the government came in and regulated them, the change is this area right here. So they could make you calculate that or do it or draw it right there. That's the change in consumer surplus that's brought about because the government has made them produce at the socially efficient level of output, right? The change in producer surplus, let me go back. Producer surplus is everything below price. So before producer surplus was the right spot here, kind of hard to do it here. Producer surplus was all this. And now the producer surplus is all of this. So the change is actually, interesting enough, this will be a hard one to do because the change is actually this because they lost that, but they gained that. So that would actually be the change in producer surplus. That'd be a really mean question to ask because it's 2 different parts, but hey, if you really understand your economics and you can draw this, then you can calculate the area of that rectangle, that area of triangle, and you should be able to do it. So, right. At a price of $13.50, where price equals ATC. So the idea here is I'm making you go right here, where price equals ATC. Price always comes from the demand curve. Is firm earning an accounting profit, an accounting loss, or zero accounting profit? So this is accounting, not economic profit. And it says explain. Tough question, because you got to know what accounting profit is. And the answer is they're actually earning a positive economic profit. No, 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 nope, nope. They're earning a zero economic profit, but that means they're earning a positive accounting profit. Let me say that again because I messed it up. When price equals ATC, they're earning zero economic profit, but they're earning a positive accounting profit. Because when they're earning zero economic profit, that means they're earning as much here as they could in their next best alternative, which is opportunity cost. And accountants don't take into account opportunity costs. And so there's actually a positive positive accounting profit here because of that economic profit. Okay, pretty much anywhere between here and here, they're earning a positive accounting profit. Now, then the question that I get asked, what about here? We don't know. We don't know the answer to that. The reason why I don't know the answer to that is we don't know what their opportunity cost is. If their opportunity cost is bigger than, what is that, $4, if the opportunity cost is bigger than $4 per unit, then they would be earning an accounting loss. If the opportunity cost is less than $4 per unit, then they'd be earning an accounting profit. But we don't know that number, so we can't give you that. And we really can't ask that question. It's not fair. Okay. I guess we could ask if we said if their accounting profit or their accounting, I mean, their opportunity cost was, and we gave you an opportunity cost, but I don't see them in, I don't anticipate them doing that in the future. So tough question right there. This is why we're doing these. So you can see these. All right, next one. Draw a natural monopoly. Okay. If the government then regulated the natural monopoly, produce the allocated efficient quantity, since the natural monopoly would have an economic loss, should the government impose a lump sum subsidy or a per unit subsidy? So the idea is I want you to be able to draw a natural monopoly and then regulate them to produce the allocated efficient point. They're then going to be earning a loss. I'll show you that in a minute. They're definitely going to be earning an economic loss at that point. So then the government needs to regulate them because you can't have a monopoly like the post office, which is a natural monopoly, and then tell them what price to charge and then have them continuously earn a loss because eventually they have to go out of business because they're earning a loss. So what you then have to do is you have to then give them money, right? And the question is, should they then give them a lump sum subsidy or a per unit subsidy? So let's do this one at a time. When you drew your natural monopoly, the idea is that a monopoly, the demand curve intersects to the right of the minimum of the ATC, but when you draw your natural monopoly, the demand curve has to intersect to the left of the minimum of the ATC. So there's the intersection of the demand and ATC. It's to the left of the minimum. So this is what your natural monopoly should have looked like. Should have had your demand curve intersecting to the left. All right. And once you do that, if this firm is producing where MR equals MC, then this firm is earning an economic loss, right? So if they regulated them to produce at the allocated efficient point, okay, and I actually didn't draw that. I thought I did. Yeah, there we go. So here it is. If we regulated them to produce the allocated efficient point, which is right here where price equals marginal cost, so if this is the quantity we made them produce, then they're going to be earning an economic loss equal to this area right here. So they are going to earn an economic loss if you regulate it. If you force a natural monopoly to produce at the allocated efficient level, they are going to earn an economic loss, the post office. And so what happens is we then have to give them money, right? And your choices are per unit. In other words, for each stamp they sell, we're going to give you money, or lump sum. And the answer is lump sum. And the reason why, if you give a per unit, then you're going to shift the marginal cost curve. Per unit affects marginal cost. And so you can't give them a per unit subsidy or this dude moves, and that point that we're trying to get them to work towards also moves. So that point right there moves, you're kind of out of luck. So you don't want that green dot to move. So what instead is you give them a lump sum, which only affects the average total cost curve. You give them a lump sum, you're giving them money, so on average their costs fall, and you want to give them enough of a lump sum subsidy to bring that lump that average total cost curve equal to price, where the earnings are a common profit. Again, tough question, but you have to know the difference between per unit and lump sum. You know that per unit affects anything that's variable, marginal cost. Lump sum only affects the average total cost, anything that's total or fixed. All right, next, explain why MR curve lies below the demand curve. Every time when we draw this guy, we do like this, and we have a downward slope in demand, and we have a marginal revenue curve that falls at a faster rate, and the question is why? Okay, the answer is that to sell another unit, firm has to lower the price on that unit and all the previous units. That means the additional revenue will decrease at a faster rate than demand. All right, so let me just kind of, oops, that's not what I want to do. Let me just kind of throw one together here. This is numbers I'm making off the top of my head, which is not smart, but I'm going to do it anyways. Now, let's suppose that I'm selling, I want to sell one unit and I want to sell it for $10. That means my total revenue is going to be $10, right? My marginal revenue is $10. The additional revenue from selling that first unit is I'm getting another 10 bucks. But if I want to then sell a second unit, I have to lower the price. And if I lower it to 9 here, then that means my total revenue is actually 18. So my marginal revenue is actually 8, which is less than the price. See, the price is the demand curve, right? And the reason why is that I had to also change the price on this one here to $9 also. I had to sell both of them for $9. So I gained 9 by selling another unit, but I lost 1 because I had to lower the price here. If I want to sell a third unit and I lower the price to 8, well, 8 times 3 is 24, right? So I really only gained $6. Why? Because 24 minus 18 is 6. Why did that happen? Well, because I gained 8 here, but I had to lower this one here to 8, so I lost 1. And I had to lower this to 8, and I lost another one, so 8 minus 1 is 6. Okay, this is why the demand curve falls at a faster rate than, I'm sorry, the MR curve, marginal revenue curve, falls at a faster rate than demand. All right, 42 minutes. There it is. Next week, I move on to the new unit, the new module, MCL. Okay. Monopolist competition and oligopoly. Have a great day.